Good afternoon. So AI is actually a very old research topic. When we say modern AI, it basically dates back to the 1950s. So the question now is, why is it that only in the recent few years, AI becomes so hot? Well, obviously, it's because advancements in computing equipment, advancements in algorithms to run AI models, but perhaps most importantly is the availability of big data, which drives the AI models. Okay. Now, at the University of Hong Kong, we have formed a team which use AI and big data to perform research related to important societal problems. One of the problems we looked at is air pollution, for example. And this project is co-led with Dr. Jacqueline Lam, also in the audience. So the Hong Kong U AI team, we have been working on this project for about 6 years. We started in 2013 when we established the Hong Kong U Cambridge Clean Energy and Environment Research Platform. So we work with different departments of Cambridge University and the University of Hong Kong. In 2017, we got the RGC theme-based research project, which is a $50 million project on using AI and big data for personalized air pollution monitoring and health management. In 2018, we formed the Hong Kong U Cambridge AI to Advance Wellbeing Society Research Platform. We also was assigned the strategically oriented research theme on AI by the University of Hong Kong. In 2017, we also established a Hong Kong U Cambridge PhD pathway, which allow Hong Kong U engineering students to go to Cambridge and obtain an MPhil in technology management from the Judge Business School of Cambridge. There are different aspects of AI research. Our focus is ethical and socially beneficial AI. For example, while we also do facial recognition, we do not use facial recognition for surveillance. We use facial recognition to identify whether people are happy, for example, with the air quality. So as I mentioned, we have a theme-based research project. We also got an ITF grant in collaboration with MIT and others, which is on IoT and smart city. And in the past few years, we have received some awards. For example, we got the Facebook Low Resource Translation Award, which is AI-based machine translation. We also have a startup, Feno Labs, which obtained the Hong Kong ICT Grand Award, and then we represented Hong Kong and entered the Asia Pacific ICT Award, and we beat out 22 countries and got the Grand Award at the Epitech. Our company also is the only Hong Kong-based startup that got funding from Horizons Ventures. This is a project that I want to share with you and to explain why we believe open data is so important. Air pollution actually has been a major problem in different parts of China. This is a website from the Environmental Protection Department. As you can see, there are 16 air quality monitoring stations in Hong Kong, and it will tell you information on PM 2.5, PM 10, SO2, and so on. Unfortunately, there are only 16 of them. So if you happen to be at the University of Hong Kong right now, or in Wan Chai, or for that matter, in most part of Hong Kong, you don't know what the air quality information is going to be. Because air quality information is very spatially structured. What that means is PM 2.5 may be 50 here, it may be 500, just a few city blocks away. So the fact that I tell you it's very good here doesn't tell you anything about whether it's good where you are located. So how do we solve this problem? The way we solve this problem is by using big data and an AI approach. We divide the city into small grids of size 100 meter by 100 meter. For each grid, we look at the data that is most indicative of air pollution. Think about it. What are such data? Vehicular traffic information, meteorology, whether there's rainfall, temperature, barometric pressure, urban morphology, where the tall buildings are, land use, is it a park, is it a school, and so on, right? We use those data as input, we train up our model, and output is the estimated air pollution for each of the 100 meter by 100 meter grid. As a result, what we have done is we have transformed the data that is available from the government, EPD, the 16 stations, we will transform it to 110,000 virtual stations. So we can give you air quality information down to the street level. If you tell me which street you are in or on, I know what the PM 2.5 is. Okay. So now I will know what the air quality in Wan Chai is, although there is no monitoring station there. Okay. Now, this allows us to do a lot of things. Okay. One of the things that we can do, of course, is we have developed apps which will tell you how to avoid the areas of bad air. Okay. But today I want to share with you this particular piece of work which was published last year. And the question is, are the poor exposed to worse air pollution? So this is an issue related to environmental injustice. Okay. Now, as it turned out, many different people have tried to answer this question. Unfortunately, without very fine-grained, geographically fine-grained description of the air quality, you cannot answer this question very well. Okay? We are now able to do so because we've used the big data and the AI approach. So, because with our AI model, we can now estimate geographically fine-grained air quality data, and our geographical unit is the constituency areas of Hong Kong, of which there are 412. Now, fortunately, from the last census, the government does release the data on the average income level, education level, whether you have a professional job and so on, for each of the 412 constituency areas. So with that, we can come up with something called a social deprivation index. The higher the social deprivation, the worse off you are. Okay? Now, with our AI model, using the proxy data, which by the way, is also available from the government. For example, the vehicular traffic is from the Transport Department, the meteorology data is from the Hong Kong Observatory, and obviously, we also rely on data from the EPD. Okay? We did get some data from the Lands Department, but they have charged us. So we hope that the Lands Department will be able to give us the data for free. But in fact, we cannot get the most fine-grained data because that would be too expensive. So we only get the sort of coarse-grained description from the Lands Department, and something we can afford. But what if they give us the fine-grained description for free? That would be great. But anyway, so with the 412 constituency areas, we can calculate the social deprivation index from the census data. With the proxy data and our AI model, we can calculate the air pollution index for 412 constituency areas. We map 412 and 412, and we find there is a statistically significant correlation that says that, unfortunately, in Hong Kong, the poorer people are actually exposed to worse air pollution. So this was actually, we had a press release, and it actually created quite a bit of interest. And within about 48 hours, we have over 30 reports internationally on TV, radio. I was on TV a couple of times and radio, and also different newspapers. Okay, so it makes us feel that with the big data and the AI technologies, we can answer some question that has not been able to be answered before. Okay, so this actually is the graph, one of the graphs. The y-axis is the mean PM2.5 exposure, and this is measured in micrograms per meter cubed. And the x-axis is the different quintiles in which we divide the 412 CAs into 5 quintiles. Quintile 1 represents CAs with the lowest proportion of socially deprived people. So quintile 1 are the most well-to-do. As you move up the quintile, quintile 5 is the worst-to-do in terms of income, education level, and so on. So you see that there is a general trend that as you move to those quintile with worse-off people, they are breathing worse air. Now, there is a little bit of a dip in the middle, okay? Now, this is because in Hong Kong, actually, as it turned out, the rich and the poor actually live very close to each other. So in some CAs, you actually have rich people and poorer people living right next to each other. But there is statistical significance in our result, okay, as I've said earlier. Okay, so this is sort of the visualization. The blue one is the air quality. The darker the color, the worse off the air. The red one is the social deprivation. The darker the color, the worse off you are socially. And you see that there is some correspondence between the dark red and the dark blue. Okay, so if you are more socially deprived, then you are breathing worse air. Okay, now, of course, there are some exceptions. One big exception is Lantau Island. Lantau Island is actually, air quality is pretty good, but social deprivation is very high. Okay. You may wonder, well, what are the worst off places in Hong Kong? So these are some of the worst. Okay, so these are some of the worst off areas. These are places like Kwun Tong, Sham Shui Po, and parts of Yuen Long. So as I've said, so environmental divide does in fact exist in Hong Kong. Okay. So the question, of course, is, okay, well, so these people are worse off, so what are we going to do about it, right? So with the data, we can actually have compensation programs. For example, the government will allocate funding so that they can plant more trees, they can make part of the city just for pedestrian, just like what they did in Causeway Bay, for example. Okay. If you want more details, this is the paper which was published in ESPN. So to conclude, our research team, we champion a lawful interdisciplinary approach, which is engineering-driven, evidence-based, societal, and citizen empowering. So before, you cannot make very strong argument because there's not enough evidence. But now we have strong evidence. And our work with Cambridge demonstrates the importance of interdisciplinary research, integrating AI, medical science, and social science so as to address important societal problems. And of course, we need data from the government to support our novel interdisciplinary paradigm. And these are the links to the websites if you are interested. And if you want more details, feel free to email me. Thank you.